In this lesson, we're going to sketch some diagrams and set up some proofs based on some given information. And in our first example, the given information is, if two altitudes of a triangle are congruent, then the triangle is isosceles. Well, since we're trying to prove that the triangle is isosceles, we'll draw a sketch of an isosceles triangle. We'll not mark it as isosceles because we haven't proved that yet. Now here's a pair of altitudes, and since we're given that the two altitudes are congruent, we made the two altitudes the same length in our sketch. Then we label the points that we think might be necessary to label, and now we'll set up the proof. We're given here that CD and BE are altitudes to the sides AB and AC of the triangle. And we're also given that the altitudes are congruent, so we state that CD is congruent to BE. And then we're trying to prove that the triangle ABC is isosceles. Another way to state this is as shown. We're given that CD is perpendicular to AB, that BE is perpendicular to AC. We can write it that way because of the definition of altitude. And then we're also given that the altitudes are congruent, so that's the same in both methods. But another way to prove that a triangle is isosceles is the statement at the very bottom, that AB is congruent to AC. Because of the definition of isosceles triangle, if two of the sides are congruent, then the triangle is isosceles. So either one of those sets of given and prove will work for this problem. Here's another one. The medians of a triangle are congruent if the triangle is an equilateral. Well, you might know what to start with. That's right, an equilateral triangle. Then we'll draw the medians as shown. We'll label some points that we think might be necessary to have labels. And now we'll set up our given and prove. We're given that AF, BE, and CD are all medians of the equilateral triangle, and we're trying to prove that all of those medians are congruent. So we state that AF is congruent to BE is congruent to CD in our line marked prove. Another way to state the given is shown here. Because of the definition of median, we could simply say that D is the midpoint of AB, F is the midpoint of BC, and E is the midpoint of AC. And then we can state that all three sides of the triangle are congruent because of the definition of equilateral triangle. And our proof statement would be the same as it was in the top method. Here's yet another problem. The altitude to the base of an isosceles triangle bisects the vertex angle. So our sketch, of course, is an isosceles triangle. And then we're going to draw the altitude from the vertex angle to the base. Label some points, and let's see if we can set up a given and to prove. Isosceles triangle ABC with vertex angle BAC and altitude AD to side BC. And given that information, we're trying to prove that AD bisects angle BAC. Another way to state this, of course, would be to just state the two sides that are congruent on the triangle, because if the two sides are congruent, it has to be isosceles. And then by stating that AD is perpendicular to BC, because of the definition, that means it has to be an altitude. And then instead of saying that AD bisects angle BAC, we'll simply state the two angles that must be congruent. In this case, angle BAD congruent to angle CAD. Two different ways to write the given and prove for the statement, the altitude to the base of an isosceles triangle bisects the vertex angle. And here's one more. If two angles of one triangle are congruent to two angles of another triangle, the remaining pair of angles are also congruent. And of course, this is a statement of what is often called the no-choice theorem. So we set up two triangles. The two triangles don't have to be congruent, but because what we're trying to prove is that if two pairs of angles are congruent, the third pair is congruent, we'll make all three pairs of angles congruent in our sketch. And then we'll label some necessary points and mark a pair of congruent angles, one from each triangle, A and D, a second pair of congruent angles. And now we can set up, we're given that angle A is congruent to angle D and angle B is congruent to angle E. And clearly what we're trying to prove is that angle C is congruent to angle F. In this lesson, we drew diagrams for problems presented with words.